Hello friends, welcome back to We Learners YouTube channel. In my previous lecture tutorial, we learned about the basic structure of the bus and bus structure, types of bus structure. Before getting into the concept, I would like to request you all to please subscribe, like, share to your friends these videos, and let's quickly recap whatever we learned in our previous lecture. So in previous lecture we learned about the single bus structure and multiple bus structure. Single bus structure, it is low cost and flexibility for attaching the peripheral devices. For multiple bus structure, better advantage is better performance, disadvantage is the increased cost, and these are the definition. Like, I will give this video in the description. Please go through the concept once and come back again to this new tutorial where I will be teaching about the performance. And the next topic that we will be learning in this lecture is about the processor clock. Okay, right, let's get straight into the concept. What is performance? In basic term, performance is something that measures the output of the work we have done. For example, let us take, you write an exam and your teachers say that you have done good, you need an improvement, and they give a statement regarding your performance, how you did your exams. So similarly, how to measure the performance of the computer. In measuring the performance of the computer is important because it tells what is the capacity of the computer, how quickly it can execute a program. So the important measure of a computer is the important measure of performance of the computer is how quickly it can execute program, how quickly, in terms, how to tell you all, it is how quickly means speed, right? It defines the speed. So the speed of the computer is affected by the design. Will you all agree with this statement? Yes, the speed of the computer is affected by the design. How can you all tell like that? Because design of three things. What are those three things that we will be studying now? So instruction set. So design of instruction set will affect the speed of computer. In what terms we are telling means, the instruction set, no, if it is more, the speed of computer will be less because it has to execute a number of instructions. Similarly, the hardware and technology which the hardware is implemented. Yes, so if the hardware can perform, if the performance of the hardware where it can execute a complicated instruction, then the speed of the computer will be more, and we our get done within a short period of time, right? So hardware, how the hardware is manufactured, and the what is the hardware and the technology used to manufacture the hardware will also affect the speed of the computer. The last thing is the software, including the operating system. If the operating system is slow, obviously the speed of the computer will be slow. About the operating system, I hope you all will be reading this subject also in your third sem. So operating system is an interface, right? It is an interface between the user application and the computer application. So computer and the application, it will provide and a medium for the application to be executed. Operating system is that. So if the operating system works slowly, obviously our applications will get slower, hence the speed of the computer will be affected. Hope you all understood whatever said still now. And let's do some quick recap. Like a performance of computer will, how can we measure that? We can measure by telling how speed the instructions get executed, and the speed of the computer is affected by design of instruction set and hardware and software. Simple, just remember instruction set, hardware, software. If you all don't remember these lines also, like speed of computer affected by instruction set, hardware, software, you all get, if this question is asked for 3 marks or something, you'll get around 1.5 mark, which is sufficient, right? So let's go into the next point. Because the program are usually written in HLL, which is high level language, performance is also affected by the compiler that translates the program into machine language. So usually you'll write the program in Java, C, C++, Python. What are these languages called? These languages are called high level languages, and these are compiled by what? These are like, compilers is what that translates the, you all know about the compiler. What it does, it translates the program into machine language which is understandable by the computer. So the performance will also be affected by the compiler, because how speed it can translate the high level language into the machine level language. So if it takes long time to convert it into this machine language, then performance will obviously go down. So this is what you all have to remember here. This point is over, so let's come to this point. For best performance, it is necessary to design the compiler machine instruction set and hardware in a coordinated way. So in conclusion, to get better performance, what we should do, we should design the compiler that we saw in the previous point, and the machine instruction set that we saw before the previous point, and the hardware in a coordinated way. I guess I know all these points are so simple that you all can remember very easily. First, like I will give you all the key points that you all have to remember here. First thing, when it comes, whenever they ask you all about the performance, remember right, only performance of the computer. So will be measured by this speed, that is how fast it can execute the program. So speed, you all know in the previous point you all wrote about the speed. It is affected by the design. So of what design it is affected? Design of instruction set, hardware, software. These 3 points you all write, like 1 2 3 all right. And then come to next point, you'll write about high level language. High level language in sense, we write the program in high level language and we convert it into the machine language, which will be converted by the compiler. So compiler will also affect the performance of the computer. In order to get a best performance or better performance of the computer, we have to design all this instruction set, hardware, software, and high level language compiler, all this thing in a coordinated way. That's all about the performance. And next we will be reading about catch. This also comes in the performance. It is a part two of the performance. What happens when the processor has a catch? So you all know catch is the fastest and smallest memory that you all will be learned in your previous sems. So examine the flow of program instruction and data between the memory and processor. To examine the flow of instruction and data between the memory and processor, how the data flow between this both, or instruction flow between the both. What we do is, at the start of execution, all program instructions are stored in the main memory. In my previous lecture video also, I have told that everything will be stored in the main memory, whether it is the data or instruction, everything will be stored in the main memory. That is what, at the start of execution, everything will be stored in the main memory is my first point. As execution proceeds, what happens? Instructions are fetched into the processor. Whenever the instructions are executed, what I will do, I will fetch whatever it is, data or instruction, I will fetch and place it in my processor. That is my second point. As instruction proceeds, as execution proceeds, instructions are fetched into the processor and copy is placed in cache. So here is a twist. In my previous lectures, I have told you all everything happens in the processor, but here I'm telling you all, whenever I'm fetching the data or instruction into the processor, I will place a copy in a cache. Why I do that? These 2 points will explain why I'm placing the instructions and data in a cache. A copy I place. Why? Later, if the same instruction is needed second time, it is read directly from the cache. So processor does the execution and it stores the result again during the execution of some set of instruction. Again, the same data is required the second time. I no need to go to the main memory again. I can, what I will do, okay, I've stored something in the cache, I have done a copy, I kept a copy of that in the cache, so I can use that. Then there will be no need of me going to the again to the main memory and getting the data into the processor. So I can easily take the data that is already the copy that I've already kept in the cache. I hope you all understood whatever I'm trying to tell you all. So next, a program will be executed faster if the movement of instruction and data between the main memory and processor is minimized, which is achieved by using the cache. This is very important whenever they ask you all about the cache. So uh, if I keep on switching from processor to the main memory, what happens? The time taken to execute the program will become more. So what happens? Performance obviously goes down. What is the main motive of us for the computer is that the instructions or program should be executed within a less amount of time. Is the main motive to achieve high performance of the computer. If there are more movements between the processor and the main memory, what happens? Performance will obviously go down. In order to avoid that, what I will do, I will keep a copy, so that cache, from the cache I will take a copy. If you'll read this line once, you all will understand, like the program will be executed fast if the movement of instruction between the main memory and the processor is minimized, which is achieved by using the cache. That's all about the performance of the computer. If there is any doubt, please let me know in the comment section. So next we will go for the processor clock. This is a simple topic. So in my previous lectures, I have told you all about the control circuitry. You all remember, I have told you all, like, control circuitry will generate a signal, that is a timing signal. So this processor circuit are controlled by the timing signal, which are generated by the control circuitry. This timing signal, we call what? This timing signal is called clock. Simple. Processor, like I will show you. Wait. In my previous lecture, I hope you all remember, like about this basic operational concept. Whenever I was telling your ALU will be there, and of below that ALU there will be a control circuitry here. I hope you'll remember that this control circuitry will generate signal whenever there is an operation to take place. So this timing signal is called clock. Clock defines the regular time intervals. Clock defines what? It defines the regular time intervals called clock cycles. Clock cycles, because you all learned about this clock. I hope you all learned about this clock cycles in your ECE concept. So regular interval of time called clock cycles, because they will not be produced. This timing signal will not be produced continuously. They will be produced within a regular interval of time, by a regular interval of time. So it is called as clock cycles. To execute the machine instruction, the processor divides the action to be performed into sequence of basic steps, such as each step can be completed in one clock cycle. So I don't get confused with this definition. In easy way I will explain you. Processor, you all know the processor is where the execution of instruction takes place. So this machine instruction will be executed in the processor only. What will this processor do? Like this machine instruction, it will divide into basic steps. Each step will be completed in one clock cycle. I hope you'll understand. If not, I will explain you all once again. Mission instruction. So the point you'll have to remember is about the mission instruction. You all know mission instruction will be executed in the processor. What this processor will do, divide the action to be performed into basic step. Means like the mission instruction, it will divide into basic step such that each step will be completed in one cycle. That's all. The length of one clock cycle is P and R is clock rate. I guess in your syllabus it is given about the clock rate. Processor clock or clock rate is all same only. Like length of the clock cycle is P. How long, for example 1 minute or something, is the length of one clock cycle, we will assume. Next, R is the clock rate. Relationship between P and R is given by R is equals to 1 by P. This is an equation. If you all write this equation whenever they ask about the clock rate, you all will get obviously 1 marks. R is measured in the terms of clocks per cycle. Clocks per cycle is nothing but hertz. I know you all know about this. You all will be learned this concept in the physics also. So all this is about the processor clock or clock rate. Hope you all understand whatever I said in this